Orion, yes.
In this area, you see a large nose portion of the shuttle known as a crew compartment trainer or CCT. The CCT was used to help our astronauts train for spatial missions. It could rotate in both vertical and horizontal positions for launch and landing procedures. Since the shuttle is retired now, this mock-up will eventually be moved to a museum. This will make more room for new ISS modules and multi-purpose crew vehicles, as well as the Orion, which is NASA's next human exploration vehicle. If you look to the left of the CCT towards the back wall, you'll see two white mock-ups of the Orion capsule. Orion is the next exploration vehicle that will carry up to 4 astronauts into deep space. It will provide emergency abort capability during the climb to orbit, sustain the crew during space travel, and provide safe re-entry from deep space velocity. The European Space Agency, in partnership with NASA, is designing and developing the service module for the Orion spacecraft. Orion will serve as the exploration vehicle that will transport astronauts to celestial bodies in our solar system, such as asteroids and moons of Mars and one day Mars itself. In the fall of 2014, NASA announced that U.S. astronauts will once again travel to and from the ISS from the United States on American spacecraft under groundbreaking contracts. The agency unveiled its selection of Boeing and SpaceX to transport U.S. crews to and from the space station using their CST-100 and Crew Dragon spacecraft, with the goal of ending the nation's sole reliance on Russia in 2017. To the back and left, you'll see a large blue structure. This structure is the 6 degrees of freedom dynamic test system, otherwise known as the docking simulator. It is used to test and analyze the new docking system. Whenever you see a spacecraft on TV, it looks as if it is just floating. However, it is traveling at an incredible speed of 17,500 miles per hour, or 28,100 kilometers per hour, which is roughly 5 miles per second, or 8 kilometers per second. To put that speed into perspective, if you take a plane flight at that speed from Houston, Texas to Paris, France, the trip will take about 17 minutes. When traveling these immense speeds, exact precision is required to dock two vehicles together. So the docking hardware and sensors are developed and extensively tested here first before attempting any docking in space. At this time, please follow me to our third stop. If y'all are on my tour, don't go outside yet. Don't go outside yet.
Don't go outside yet.
The large white pole directly in front of us is a functional model of the onboard ISS arm, also known as the robotic vision platform. It is designed to work in Earth's gravity, unlike the ISS arm. It helps train the astronaut crew for construction of the ISS. Now to our left, you'll see our new space vehicles. These are the Space Exploration Vehicles, or SEVs. The surface exploration version of the SEV has the cabin mounted on a chassis with wheels that can pivot 360 degrees and drive about 6 miles per hour, or 10 kilometers per hour, in any direction. It's about the size of a pickup truck and can house 2 astronauts for up to 14 days, with full sleeping and sanitary facilities. The rover has 6 pairs of wheels which can move independently from one another. This style of steering allows the vehicle to turn on a dime with a 0-degree turning radius and drive in any combination of forward and sideways. NASA has developed